All right. So yesterday we solved questions till this point, right? So questions based upon vertical circular motion. So now next we will solve questions based upon the spring block system. Okay. So we had covered the theory of spring block system in the earlier lecture, in yesterday's lecture, right? In yesterday's lecture. So let us solve the questions. Okay. So two springs A and B having spring constant Ka and Kb. So Ka is equal to 2 times Kb are stretched by applying a force of equal magnitude. So there are two springs A and B. Okay. So this is spring A, this is spring B, and you are exerting same force on these two springs. So same force F and F, right? So question is, if energy stored in spring A is Ea, then energy stored in the spring B will be. Okay, so spring constants are given. K is equal to 2 times Kb. So forces are equal. Okay, forces are equal. See, question is two springs A and B have spring constant Ka and Kb. K equals to 2 times Kb. Okay, they are stretched by applying a force of equal magnitude. So force is equal. Okay, if energy stored in spring A is Ea, then energy stored in the spring B will be. Okay, see. So force, the spring force is minus of K into X in magnitude, right? So now energy stored, we have this formula half of K into X square. So because force is equal, I will manage force in this formula. Okay, I am given with K, right? I am not given with X. Okay, X is not given. So what I will do is I will multiply with K so that this becomes K square X square, and I will divide by K. Okay, so this becomes half of Kx square, which is 4 square F square, right? F square divided by K. This is my formula for energy. Okay, so force is constant, right? Force is same on A as well as B, spring A as well as spring B. So you can write that energy is inversely proportional to K. So EB upon EA will be equal to what? It is inversely proportional. So it is Ka upon Kb. And you want energy of B. Okay. And K is equal to what? 2 times Kb. So this is 2 times Kb. So 2 times Kb upon Kb. Kb cancelled. So EB is equal to, take that EA on other side. So it is 2 times EA. So this is the answer. Now is it clear? So let us see next problem. So this is from NEET 2003. When a long spring is stretched by 2 cm, its potential energy is U. If the spring is stretched by 10 cm, the potential energy stored in it will be. So this is very simple. What is potential energy? U is equal to, or let's call it U1. U1 equals to half of K times x1 square. And U2 will be equal to what? So U2 will be equal to half of K times x2 square. Okay, so this half K and half K, if you divide, half K and half K gets cancelled. It is x2 upon x1 square, right? U2 upon U1 will be x2 upon x1 square. So how much is x2? Okay, it is 10 centimeters. X1 is 5 centimeters. So you get U2 equals to 10 by 2 square. X1 is 2 centimeters. Okay, 10 by 2 square. Okay, times U1. So it is 5 square, 25 times U1. This is the answer. Next question. A mass of 0.5 kg moving with a speed of 1.5 meters per second. So this mass, it's moving with a speed of 1.5 meters per second. on a horizontal smooth surface. So this is horizontal smooth surface. Okay, so its speed will not change. Collides with a nearly weightless spring, collides with the spring, okay, of force constant K equals to this thing, 50 newtons per meter. The maximum compression of spring would be. So tell me, what will happen? So this mass will collide with that spring. The spring will get compressed. Okay, and now this mass is doing some work on spring because it is compressing the spring. Okay, so its energy slowly and slowly gets converted to what? It gets converted to the potential energy of the spring, right? So it is losing the kinetic energy, and that kinetic energy gets converted to potential energy of spring. So there will be one point where that mass will stop. When will it stop? When its total kinetic energy gets converted to the potential energy of the spring. Okay, so it's simple then. The maximum compression will be when the I'm sorry, it will be when the total kinetic energy of this mass, which is half of mv square, gets converted to the potential energy. So half of k into x square, right? So half and half gets cancelled, and you want to find out the maximum compression. So x is what you have to find out. So x square equals to mv square divided by k, and that means x is equal to mv, sorry, m upon k square root of this multiplied by v. So that is, how much is m? It is 0.5, right? 0.5 divided by k is 50 multiplied by v is 1.5. So 0.5 divided by 50. Okay, so it is what? 1 upon 100, right? If you multiply and divide by 2. So if you multiply this by 2, this will be 1, this will be 100. So it is 1 upon 100. Square root of that is 1 upon 10. So 1.5, sorry, 1.5 divided by 10 is how much? 0.15. So 0.15 meters is the answer. The potential energy of a long spring when stretched by 2 centimeters is U. If the spring is stretched by 8 centimeter, the potential energy stored in it is. You tell me. Very good. Option D, right? This is straightforward. Okay, everybody. Okay, so this is option D. And they have repeated this question. Okay, 2006 and 2003. Okay, next question. A vertical spring with force constant K is it, sorry, a vertical spring with force constant K is fixed on a table. A ball of mass m at height h above the free upper end of the spring falls vertically on the spring so that the spring is compressed by distance d. The net work done in the process is. This is the question. Okay, so this is simple. See, there is this vertical spring fixed on a table. Okay, and there is a mass which falls from some height h. Okay, it's given that it falls from this much height h, and then the spring gets compressed. So compression in the spring is suppose this much. Okay, suppose it is this much. It's given to be d. So how much is the total work done? So what will be total work done? One is the work done on this mass, okay, due to the gravity, you can say, right? It is mgh plus d. Okay, and work done on the spring is how much? Half of k into d square. So which is the answer? See, okay, you can see it in this way. Okay, so now that mass, it is losing its potential energy. Yes, no? Let's find out total change in potential energy. Okay, total change in potential energy. So this mass, okay, it is losing the potential energy, right? So its change in potential energy will be minus of mg multiplied by change in height, h plus d. Okay, and the spring is gaining the potential energy because the work is done always against the spring force. Okay, so spring is gaining the potential energy. So change in its potential energy is half of k times x square, and the work done will be what? Opposite to the change in potential energy. Opposite meaning negative of change in potential energy. So tell me, work done will be equal to what? Minus of change in potential energy. So that is mgh plus d minus half of k times x square. So option A is the answer. Got it? The explanation. Okay, why this negative sign? Why not positive? Right? This is conceptual point, right? The mass is losing its potential energy, the spring is gaining. So change in potential energy of the mass is negative. Okay, change in potential energy of spring is positive. Okay, and work done is equal to what? Negative of the total change in potential energy. And that's why we have mgh plus d minus half of k into x square. Right? So yes, let's see next question. A block of mass m is attached to the lower end of a vertical spring. Okay, there is vertical spring like this, and you attach a mass m. Okay, and then the spring is hung from a ceiling. So spring is hung from a ceiling. Okay, and it has force constant value k. The mass is released from rest with the spring initially unstretched. The spring is initially unstretched. Okay, the maximum extension produced in the length of spring will be, what will be the maximum extension produced in the length of the spring? Okay, who can tell? All right, see what will happen. You release that mass. Okay, so the spring is unstretched initially. So now the mass is connected to the spring. If you release it, there will be some extension in the spring. So when there is an extension, what happens? The potential energy of mass increases or decreases? The potential energy of mass decreases, right? And it is equal to increment in the potential energy of the spring. So can I say this? Okay, the potential energy of mass will decrease because it is falling down, so its height will decrease. Okay, but spring is getting stretched, so its potential energy will increase because there will be work done against the spring force. So this is mg h, suppose, is the decrement in the potential energy of the mass. So it is equal to, okay, or let's call it, instead of h, let's call it x only. Okay, right? So mgx is the decrement in potential energy of mass. So increment in potential energy of spring is half of k times x square. So x and x gets cancelled out. Okay, So then you take that 2k on other side. So you get x equals to 2 times mg divided by k. This is the answer. Which option? Option A. Okay, this is the answer. So next question. Two similar springs P and Q have spring constants Kp and Kq such that Kp is greater than Kq. They are stretched first by same amount, okay, then by same force, case B. The work done by the springs Wp and Wq are related as in case A and case B respectively. So when they are stretched by same amount, we can say work done is equal to what? Half of k multiplied by x square. This is the relation. Okay. And when they are stretched by same force, we have just found that for same force work done we can write it as half of k square x square upon k, right? So we'll multiply and divide by k such that numerator is what? Force square, because kx is the force. So it is f square upon 2k, right? So in first case, we'll use this formula. In second case, we'll use this formula. So which is the answer? So Kp is greater than Kq. Okay. So Wp upon Wq is equal to, so half of Kp times x square upon half of Kq times x square. So when they are stretched with equal distance, right, same amount. So Kp is greater than Kq, that means Wp will be greater than Wq, right? Wp is to Wq is Kp is to Kq. So Wp will be greater than Wq, right? And in second case, what will happen? So it's inversely proportional to K when they are stretched by same force. So in second case, Wq will be greater than Wp, because work done is inversely proportional to K. If K is more, then work done will be less. If K is less, work done will be more. So Kp is greater than Kq. So work done on Q will be greater than work done on P. Wq will be greater than Wp. Okay. So yeah, Sanjay is saying option A. Is it the option A? Wp is greater than W. Right. Option A is the answer. Next question. A spring with force constant K is initially stretched by x1. If it is further stretched by x2, then the increase in its potential energy is. This is the question. So initially it is stretched by x1. Then it is further stretched by x2. Okay. So what will be total stretching? x1 plus x2, right? So final potential energy can be written as what? Half of k multiplied by total stretching x1 plus x2 square. This is suppose u2. Okay, and u1 can be written as half of k multiplied by x1 square, right? So increase in its potential energy when it is further stretched by x2. Okay, that's what we have to find out. So it will be equal to u2 minus u1, right? It will be equal to u2 minus u1, and that's equal to. So for that, we have to expand this square. Okay, half k we can take common. Then it will be x1 square plus 2 times x1 into x2 plus x2 square minus x1 square. So this x1 square and x1 square gets cancelled, and then we are left with half k multiplied by the remaining thing. So yeah, we can take x2 common. So it is half k multiplied by x2 multiplied by 2x1 plus x2. So option B, it seems. Okay, option B is the answer. Next, let us see when there is some loss. Okay, so when there is some loss in energy, how to solve the problem. Okay, so problem is a body of mass 1 kg is thrown upwards with a velocity of 20 meters per second. It momentarily comes to rest after attaining a height of 18 meters. How much energy is lost due to air friction? This is the question. So see, it has some velocity 20 meters per second. Okay, so its kinetic energy gets converted to what? Potential energy. When it attains some height, the kinetic energy gets converted to potential energy. So P at height H, you can say, plus there is some loss. Okay, and that's what we have to find out. How much is the lost energy? Okay, so loss, okay, or lost energy, that's what we want to find out. Okay, so now kinetic energy is half of m into v square, and it is equal to potential energy at height h, so mg h. Okay, we want to find out lost energy, no? So let's take that potential energy on other side. So lost energy will be equal to kinetic energy, which is half of m into v square, minus potential energy, which is mgh. So what is its mass? 1 kg. So 1 multiplied by v square is 20 square, minus mgh. So m is 1, g is 10, h is what? 18. Okay, it attains the height of 18 meters, right? So how much is the energy loss due to the air friction? So this is equal to 20 square is 400. 400 divided by 2 is 200, minus this is 18 times 10 is 180. So 20 joules is the answer. Option D. Okay. So let's see next question, and you will tell me answer of this. 300 joule of work is done in sliding a 2 kg block up an inclined plane of height 10 meters. Work done against the friction is. 300 joule of work is done in sliding a 2 kg block up an inclined plane of height 10 meters. Okay, work done against the friction is. Tell me. See, 300 joule is total work done. I can say total work done when you move this block. Okay, 2 kg block from here to here. So there will be some work done against the gravity, right? Which is equal to what? mgh. So work done against gravity, which will change its potential energy. Okay, plus if there is some friction, then there will be some energy lost in friction. Okay, so work done against friction, right? Can we say this? It is change in potential energy of the block plus work done against the friction. So this is equal to 300 joules. Okay, this is given. And how much is change in potential energy? So it is 2 times. So it is mgh, right? This is mgh. Okay, plus we want to find out work done against friction. Okay, mgh is what? 2 times g is 10 and height is 10. So 2 times 10 into 10, 100. So it is 200 plus work done against friction. Okay, so how much is work done against friction? Work done against friction is equal to 300 minus 200. that is 100 joules. Okay, straightforward and very simple question. Option C is the answer. So let's talk about the power. What is power? Power is rate of doing work. What is power? Power is rate of doing work. Work done per unit time, you can say. Okay. So for an example, there are two friends. Okay. Let's call them Ajay and Vijay. So Ajay and Vijay, they have same mass. Okay. And they climb up a staircase. So let's suppose they are going to some temple. Okay. So the temple has a huge staircase, okay, to be climbed to reach that temple, right? So they climb up this staircase and they have a race. Okay. So let's suppose, okay, so they decide that whoever reaches first will get, let's suppose, 100 rupees or something, some prize from the other or some party. So their masses are same, masses are equal. Let's say 50 kg and 50 kg. And so this is Ajay and this is Vijay. Okay. So Vijay reaches first. Okay. And the time taken by Ajay is twice as that of Vijay. So who is more powerful? Of course, Vijay is more powerful, right? Because he is doing that work. So when he climbs up the staircase, he's doing some work against the gravity, right? He's doing some work against the gravity. How much is the work done? mgh. Their masses are equal. Vijay reaches in half of the time. That means his power is twice as much. Okay. So power can be defined as work done per unit time. This is the average power. Okay, this is the average power, work upon time. If you want instantaneous power, this is what? This is average power. Okay, the instantaneous power. So what will be instantaneous power? It is rate of change of work with respect to the time, right? It is rate of change of work with respect to the time. And work done can be written as what? So it is d by dt of f dot dx, right? And if force is constant, if force is constant, you can take it out. Okay, so it will be d of dx by dt. Okay, so rate of change of position, you can say. So let's call it displacement only. So rate of change of displacement with respect to time. What's that? It is the velocity. So this can be written as what? It is force times velocity is the instantaneous power. Okay. So the average power is just work done divided by time. The instantaneous power is rate of doing work. That means there is derivative involved. Okay, so it is dw by dt and it is equal to what? If we substitute w equals to f times s, force times displacement, and if force is constant, we can take it out. So then it will be f multiplied by d by dt of s. D by dt of s is what? Velocity. Okay, so you get instantaneous power equals to f times velocity. So is this clear? The talk went in some other direction. All right, so power, yeah, we were discussing about power. So instantaneous power can be given by this formula, and work done can be also written as change in energy, right? It is equal to change in potential energy. Okay, minus of change in potential energy, or it is equal to change in kinetic energy, right? So rate of doing work dw by dt can be also written as what? Minus of du by dt. So there is this another formula for the power, minus of du by dt. And there is one more formula. So because dw, okay, let's talk about small work. Let's call it delta. Okay, so delta w is equal to what? Delta k, change in kinetic energy, right? So dw equals to, we can say, or I will erase this all to stay consistent with the notations. Okay, so work done can be written as what? Let's suppose there is small work done. It can be written as change in kinetic energy. Okay, so the power has another formula if there is kinetic energy involved. Okay, if you know about the kinetic energy, if there is kinetic energy given in the problem. So the power is equal to dw by dt, or you can say it is equal to dk by dt. Okay, so what is k? K is kinetic energy, right? So since work done is equal to change in kinetic energy, power is equal to what? The rate of change of kinetic energy with respect to time. And then we have another formula. Since work done can be written as change in potential energy, minus of change in potential energy. Okay, so power can also be written as what? Because it is dw by dt, it can be written as minus of du by dt, right? A body of mass 1 kg begins to move under the action of a time dependent force F equals to this thing, okay, 2t into I cap plus 3t square into j cap newtons, where I cap and j cap are unit vectors along x and y axis. What power will be developed by the force at time t? Okay, so this is straightforward question. What power will get developed? So power is equal to what? The instantaneous power is force times velocity. Okay, force is a vector quantity, velocity is also a vector quantity. So it is dot product of force and velocity. Okay, so that means we have to find out the velocity. Okay, so this is the force, right? And mass is given. That means you can find out the acceleration. And since mass is just 1 kg, so acceleration, which is force upon mass, okay, and it's a vector, so it will be equal to what? 2t times I cap plus 3t square times j cap, and it begins to move under the action of this time dependent force. Means its initial velocity is what? Since it begins to move, that means its initial velocity is 0. Okay, so what will be final velocity? So v will be equal to, see, you can write acceleration equals to dv by dt. Okay, and then you can write, you can take that dt on other side. So dv is equal to a dt, and if you integrate it from 0 to t, you get change in velocity. Okay, so this is v minus u, right, equals to integral of a dt from 0 to t. But initial sorry sorry the initial velocity is 0 because it begins to move, it's given. So u is 0, right? And v is a vector because, okay, v is a vector quantity, a is also a vector quantity. Okay, so u bar is 0. Okay, so v bar is equal to integral of a bar times dt, and you have found a bar 2t into I cap plus 3t square into j cap. Okay, so do the integral. So integral would be simple, right? So 2 times t, 2 you can take out, into I cap 2t dt into I cap plus 3 times t square dt into j cap. Right? What will be the integral? So this is t square upon 2. This 2 gets cancelled. This is t cube upon 3. Right? Integral of this is t cube upon 3. 3 and 3 gets cancelled. So what do you get? V bar equals to t square into I cap plus t cube into j cap. And then you multiply force with velocity. What do you get? 2 times t multiplied by t square, which is 2 times t cube into I cap plus 3 times t square multiplied by t cube. So it is 3 times t raised to 5 times j cap. Okay, this is the power. So, okay, these many watts. Okay, one thing I forgot to tell you, the unit of power is watts, right? And one more thing, I did a mistake here. I dot I is what? Is 1. J dot J is also 1, right? So what do you get? These many watts. This is the answer. Option B. So let's move on to the next question. So a particle of mass m is driven by a machine that delivers a constant power k watts. If the particle starts from rest, the force on the particle at time t is. This is the question. Okay. So we know that power is equal to what? Force multiplied by velocity. Right? Power is equal to force multiplied by velocity. And what's given? That power is constant. And how much is the power? It's equal to k. Okay. So we know if that force acts on the particle, okay, and it changes its velocity, okay, it changes its velocity. So there will be some change in kinetic energy, right? Okay. So work done here will be equal to what? Change in kinetic energy. So delta Ke, okay. So that is equal to half of m into v square minus half of m into u square. And the particle starts from rest. So this will be equal to 0, right? Initial kinetic energy will be equal to 0, okay? And the power can be written as what? Work done upon time. So what is work done? It is power multiplied by time. Okay, so this is power times time. And initial kinetic energy is 0. So this term is 0. And power is given to be k. So k times t is half of m into v square. Okay, this is what we got. And we want to find out what? We want to find out the force. Now it's simple. Okay. So from this we can find out velocity. Okay. So we get v square equals to 2kt upon m. Therefore v is equal to square root of 2kt upon m. Right. And we can substitute this here. Okay. So force is equal to power divided by velocity. So what is power? Power is k divided by square root of 2kt upon m. Okay, this is the value of force. Which is the option? So we can simplify this. Okay, this k and the square root of k, it will get cancelled, right? I mean, the square root of k will remain there. And this square root of m is in denominator. You can take it to the numerator. Okay, so this will be equal to what? So square root of mk in the numerator and 2 in the denominator. We can take 1 by 2 out. Okay, it will be root of 2 actually, not 1 by 2, root of 2, and then t we can take out and it's in denominator. So in denominator it is t raised to half. So in numerator it is t raised to minus half. Right. So which answer? Which is the option? Option C, right? Okay. Yes or no? Alright. Let's move on to the next question. One coolie takes 1 meter to raise a suitcase through a height of 2 meters. But the second coolie takes 30 seconds to raise the same suitcase to the same height. The powers of two coolies are in the ratio. You tell me. This is very simple. Second coolie takes half of the time. So that means second coolie is option, it has to be option D, no? Option D. Okay, second coolie does it in half of the time. So second coolie is twice as much powerful. Okay, option D is the answer. Right, Sanjay? All right. So this was the easiest question. Okay, it can't get easier than this. This is clear, no, everybody? Okay. Next question. A car of mass m starts from rest and accelerates so that the instantaneous power delivered to the car has a constant magnitude P naught. Okay. So again, it is constant power question. The instantaneous velocity of the car is proportional to. So it starts from rest. Okay. And we have seen this formula for the power. So power is equal to what? Rate of change of kinetic energy with respect to time. Okay. And we want the instantaneous velocity. Okay. So now since the power is constant. Okay. Since the power is constant, the instantaneous power and average power will be equal. So we can just say this is equal to change in kinetic energy, final kinetic energy minus initial kinetic energy divided by time, because the power is constant only. Okay. So you can move this time on the other side. Okay. So for, okay, work done is equal to what? It will be power multiplied by time. Okay, because power is just constant. So P equals to W upon T you can say, or W equals to P times T, which is equal to change in kinetic energy. Okay, and it is, power is given to be P naught. So it is final kinetic energy minus initial kinetic energy. And it starts from rest, right? The object, the car starts from rest. It's given. Okay, so initial kinetic energy is 0. Right, initial kinetic energy is 0, so this is equal to final kinetic energy only. So this is half of m into v square. So now you want velocity is proportional to what? Okay, so you can move this 2 and m on other side. So what do you get? So you get v square is equals to 2 times p naught times t divided by m, and then therefore v is equal to what? Square root of that. So 2 times P naught upon M. This is constant. Okay. And you have square root of T also. Okay. So T raised to half, or square root of T, you can say. So which option? Option B, I guess. Option B is the answer. A body projected vertically from the Earth reaches a height equal to Earth's radius before returning to the Earth. The power exerted by the gravitational force is greatest at the highest position of the body at the instant just before the body hits the earth, it remains constant all through and at the instant just after the body is projected. Which would be the answer? Now, this is, let's suppose, earth, and there is some body projected from earth. So we can say a rocket, okay, projected from earth, right? So we know the formula for gravitational force. It is equal to g into mass of earth multiplied by mass of rocket upon r square. This is the formula for the gravitational force between two bodies, right? G into mass of earth multiplied by mass of rocket upon r square. So as the rocket goes away, what will happen? The force between the rocket and earth will decrease, right? The force will decrease. Okay. So, and one more thing. So it is projected vertically upwards and it reaches to some height. So when it reaches to some height, what will happen? Its velocity will become what? Zero. So its velocity is maximum when it is at the earth's surface. Okay. And force is also maximum when it is at the earth's surface. As distance increases, what happens? The velocity also decreases and force also decreases because it stops at some height. Okay. So the power is force multiplied by velocity. Okay. When will it be maximum? You're saying option C? No, it doesn't remain constant all through. When it is on the earth's surface. Now at the instant just after the body is projected, this is one option, and at the instant just before the body hits the earth, this is another one. So which of these two will be correct? B or D? Because it will hit with the same velocity also. Yes. So see, when it is projected, the velocity is upwards and force will be in downwards direction. Okay, and this is dot product. Okay, and when it comes back, so while the rocket comes back on the earth, okay, its color will not change. Okay, so velocity is in this direction and force is also in this direction, right? Because earth is always pulling it. Okay, so what will happen? So in this case, the product of dot product of force and velocity, it is F multiplied by B multiplied by cos of 180 degrees when it is projected upwards. When it reaches back, it will be F multiplied by V multiplied by cos of 0, and cos 0 is 1 and cos of 180 is minus 1. So it is greatest when it comes back. Okay, because in that case power will be positive. Yes, no? Okay, so at the instant just before the body hits the earth, this is the answer. Everybody got it? Okay, good. Okay, good. So let us see next question. An engine pumps water through a hose pipe. Water passes through the pipe and leaves it with a velocity of 2 meters per second. The mass per unit length of water in the pipe is 100 kg per meter. What is the power of the engine? Okay, what will be power of the engine? So here velocity is given, right? Velocity is given. So this is suppose the hose. So water comes out of this hose, right? So it comes out with some velocity. So now power can be written as what? half of mv square, change in kinetic energy with respect to time. Okay, half mv square divided by t. So what are we given? We are given the velocity. So v we know, and mass per unit length. Mass per unit length is what we know. Okay, time also we don't know. So mass per unit length. So this is, suppose length equals to 1 meter. Okay, this length is 1 meters. So mass in this much length is given. Okay, so how much is the velocity? So m upon L is given, right? M upon L, mass per unit length is given. Okay, so per 1 meter, how much mass is there? 100 kg. And how much is the velocity? It is 2 meters per second. So how much length of the water is coming out per second? 2 meters, right? 2 meters is coming out. Okay, so how much mass is coming out? So 1 meter contains how much mass? 100 kg. So 2 meter will contain how much mass? 200 kgs, right? So we can say m upon L is given. Okay, so m upon L multiplied by L, this will give us the mass. Okay, we can put it over here. So what do we get? We get power equals to half of m upon L, mass per unit length is given, multiplied by L into v square upon t. And what is L upon t? It's the velocity, right? The length covered, okay, divided by time taken. It's the velocity. So this is equal to half of m upon L multiplied by velocity into velocity square. So it is velocity cube. So this is equal to half of m upon L is 100 multiplied by v cube. We have v is 2. We have 2 raised to 3, which is 8. 8 upon 2 is 4. 4 times 100, 400 joules. Sorry, what joules? This is power. So 400 watts is the answer. Okay. So option A. A particle of mass m starting from rest undergoes uniform acceleration. If the speed acquired in time t is v, the power delivered to the particle is. This is very simple. So speed acquired, yeah, option D. Very good. Option D will be the answer. Right? Starts from rest. Okay, so how much is change in kinetic energy? Final minus initial. Initial is 0 divided by time. So this is the power. Power is change in kinetic energy divided by time. So final is half of m into v square. Right? So this is the answer. Okay, final kinetic energy is half of mv square. Initial is 0. So final minus initial upon time is the power. So this is the answer. Straightforward. Okay, good Sanjay. Got it, everybody? Yeah. So this was second simplest question, you can say. Okay, first one was that, the coolie question, right? That one or other one? That one only, no? Yeah, that one was simplest. Okay, next question. Water falls from a height of 60 meter at the rate of 15 kg per second to operate a turbine. The losses due to frictional forces are 10% of energy. How much power is generated by the turbine? This is the question. Okay, so there is some loss. Okay, so how much power is generated is the question. Water falls from a height of 60 meters. at the rate of 15 kgs per second. Okay, so it falls from height. mgh is its potential energy. Okay, and per second, how much potential energy is delivered? So we can divide it by time. So this is the input power, you can say. Okay, and since there is 10% loss, that means how much power would be delivered? So power delivered, okay, to the turbine, P will be equal to input power multiplied by 90% because 10% is lost. Okay, so 90 upon 100. So mgh, so you are given m by t, okay, is 15 kgs per second, right? It falls at the rate of 15 kgs per second. That means you are given with m by t. Then you can substitute the values. So m by t, this is 15, g is 10, and h 60. Okay, so it is 15 times 10 times 60 multiplied by 90% or 0.9 you can say. So how much is it? 15 times 6 is 90. Okay, 9,000 multiplied by 0.9. Okay, 9 nines are 81. So 8,100 watt, or you can say 8.1 kilowatt. This is the answer. Option C. Okay, this question. Tell me, you can solve this. Very straightforward. If force is this, velocity is this, instantaneous power is. Okay, third simplest question we can say. So it is just equal to what? F bar dot V bar, the dot product. Okay, so it is 60 times 2, 60 times 2 plus 15 times minus 4 plus minus 3 times 5. How much? 120 minus 15 times 4 is 60 minus 15. Okay, so 60 minus 15, 45. 45 is the answer. Okay, option B. Yes, very good, Sanjay. So how much water a pump of 2 kilowatt can raise in 1 minute to a height of 10 meters? This is the question. Okay, so 2 kilowatt is the power. So power is equal to, you can say, mgh upon T. So mgh is equal to power times T. So mass is equal to what? P times T upon gh, right? And now we can substitute values. So power is 2 kilowatt, that means 2000. Okay, multiplied by time. Time is how much? 1 minute. So 60 seconds divided by gh. So gh is, g is 10, h is 10. So this thing and two zeros gets cancelled. 200 times 6, 1200. Okay, 1200 kg is the mass. Okay, and answers are given in liters. So see, mass can be written as density multiplied by volume, and density of water is 1 kg per liter. Okay, so density is 1 kg per liter for water. Okay, so therefore volume would be equal to what? 1200 liters. So that's the answer, option B.